Number 8, another word problem. So let's read it. An internet store, or some store on the internet, sells blankets. If the store sells X blankets at a price of P dollars per blanket, then the price demand equation is given by this rule right here. So you're going to see price demand equations come up a lot for the rest of the course. It's basically just an equation that tells you if you know how many, in this case, blankets are being demanded, that's X, you can plug it in and figure out what price those blankets were set at to make that demand happen. Or vice versa. If you know the price of the blanket, you can work backwards to figure out what X is, what demand was created by that price. They're related by this rule. And this rule is an exponential function. Right now it's written in equation form with a P equals, but I could rewrite that as f of x notation to show that the input x is going into the exponent, but instead of an instead of an f for the function notation, it'd make more sense to use a p of x to remind us we're calculating the price. So this is to remind us that we're going to input what? What is our input? What is x again? Yeah, it's the number of blankets that the store sells. And if we input that amount and follow this rule, our output is going to be the price per blanket at that level of demand. So our output is going to tell us the price in dollars that created that demand of X blankets. Maybe 100 blankets, maybe 1,000 blankets. Okay. So we're being asked to find both the price and the rate of change of price. So we need to find just straight up P, and we need to find P prime. When the demand is 800 blankets, the number of blankets was an input. So that just tells me my X is going to be 800. And I need to input that X into the P function. And I need to input that X into the P prime function. Okay, well, we have the P function. Let's find the P prime function. Then we'll plug in the 800s. And then we'll do our interpretation. Okay, so I wrote my generic exponential rule for derivatives out here. And I know, again, this is an exponential function because my input is being sent to an exponent. And I have a constant base. So I have a constant base, a variable exponent. Okay, so our rule tells us to find the derivative. I start by just rewriting whatever the exponential expression was. So I'm going to rewrite 350 times my constant base raised to the x power. Then I'm going to tack on the natural log of the base. So I'm going to multiply by the natural log of whatever the base was. And the base was, in this case, this decimal number. So 0.999. Okay. And then the chain rule came in. Here comes the chain rule. Let me shrink all this for a sec just so I have some more room. Okay. So remember, the chain rule takes the derivative of wherever that input was being sent. So in the exponential function, the input was being sent to the exponent. So my chain rule is going to tack on the derivative of the exponent. Now, in this case, my exponent was just a plain old x. So I'm just tacking on the derivative of a plain old x. And we know that's just 1. So if I wanted to clean this up, then my derivative would just be 350 times my constant base raised to the x power times the natural log of that constant base times 1, but we don't really need that times 1, so I'm not going to write it. Okay, and now I have my original function. I have my derivative of the function. I can plug in 800 to each of those rules. So let's do that. If I input 800 into the original function, that's this one up here, my rule says I'm going to do 350 times this constant base raised to the 800 power. So type that in on your calculator. Okay, I got approximately 157.22202, but I rounded to the nearest penny because remember, we were calculating an output of price. So this is going to be a dollar amount. And then when I plug P into my derivative rule, the derivative rule says you're going to do 350 times the constant base raised to the input, which is 800. And then I need to multiply by the natural log of that constant base. I don't know. Let me plug that in my calculator, and I have a feeling I'm going to round that too. So I'll put my squiggly equal signs. Okay, I got negative 0.15728. Now, if we're talking about money, I need to round to the nearest hundredth, the nearest cent. So this would be approximately negative 0. If I round, it's going to be 16 cents. So here my derivative, my rate of change is negative. So I have to be careful when I go to interpret. So let's go ahead and do our interpretation. In both of these cases, my input is 800 blankets. And that input was representing a demand. So I'm going to start my interpretation by saying a demand of 800 blankets, what? Well, it corresponds to this output, which was the price. So demand of 800 blankets creates, or maybe I say is related to, or the price that is created by a demand. Okay, so I'll say creates a price of, oh my God, that's an expensive blanket, of $157.20 per blanket. Holy smokes. I don't know, some blankets are expensive, I guess. Comforters. And what's happening to the price? It's a negative derivative. So that price is it's on the way down. Later we'll see how demand and price are related. And a lot of times as demand is increasing, price is going down. They're inversely related like that. Not all the time. But as things get more expensive, fewer people are willing to buy them typically. So, you know, as I jump to those higher prices, I would expect my demands to go down, but I don't know. That's just happening in this case. So I would say, okay, and the price is decreasing by what? Well, to help you get that interpretation correct, let's come back over here to the derivative and write the derivative as a fraction. Oh, I shouldn't put my dollar sign there yet. I'm going to write this derivative as a fraction. I'm putting it over a 1. And my output is telling me the price, how the price is changing, which would be dollars. And the input was telling me number of blankets. So this is the price per additional blanket. So the price is decreasing by 16 cents, approximately. I should put approximately since I rounded. By approximately 16 cents per each additional blanket being sold. So being demanded. Each additional blanket being demanded. Yeah, that is kind of a weird scenario. But just a couple things to point out. So our input was 800 for both of those, and our input was describing the demand, the number of blankets being demanded. This output right here of $157, that was, this output right here. So this number right here, this was my P of 800. And then this output, oh my gosh, Kelly, focus. This output, so this number, this was my P prime of 800. And I needed to have that word per in there That is important because it's a rate. That fraction is telling me I'm comparing two things and comparing how outputs are changing compared to inputs. That's a rate, so I had to have that rate in there. Okay, I know this is a lot. I know it takes a lot of practice. Again, as a reminder, my MathLab homework has multiple choice options for the interpretations, but your test will not be multiple choice. So try to write a sentence on your own, then read through the options and see which one matches. And if you're not sure if what you wrote is correct, snap a picture and email it to me, and I can give you the thumbs up or point you in the right direction.